Let us recap lesson 2 and lesson 3. Let us look at the impact again of the value of a on the following 5 functions. The first function being f of x equals to 2x squared. The second one being f of x equals to 3x squared, all with a values greater than 1. We compare the first two with the base function f of x equals to x squared. After the comparison of these two graphs with the base function f of x equals to x squared, we do the same comparison, taking 3 functions with a values between 0 and 1. That is, 3 functions with the value of a less than 1, comparing them with the base function f of x equals to x squared. Let us first start by plotting the value of f of x equals to x squared, as we have done in the previous 2 videos, using 3 points. Remember, the 3 points we used are -1 and 1, which is a point on this Cartesian coordinate right there, and the second point is 0 and 0, which is in the middle, and the third point was 1 and 1, which is a point right here. And we went ahead and joined our 3 points to get the parabola y equals to x squared. We have now plotted the function f of x equals to x squared. Let us now plot the function f of x equals to 2x squared. In this case, the 3 points we're going to have are -1 and 2, 0 and 0, 1 and 2. When we join the points, we will get a parabola resembling the following parabola. The equation y equals to 2x squared. And finally, let us plot the parabola with the a value 3 with the function f of x equals to 3x squared. Our 3 coordinates will be -1 and 3, which is a point somewhere around here. The second point is 0 and 0. The third point is 1 and plus 3, which is a point around here. Let's join 3 points. We'll get the parabola that looks as follows. Now these are our 3 parabolas with the equation y equals to x squared, y equals to 2x squared, and y equals to 3x squared. Now we can clearly see the trend that as the a value moves from the value of 1 to 2, from 2 to 3, the parabola gets thinner and thinner. That is, it gets thinner and thinner. Now let's switch to plotting the 3 parabolas with a values less than 1 but greater than 0. Our first point in this case will be a 1 and 0.8. That is, for this parabola, it will be a 1 and a 0.8. 0.8 is a point somewhere around here, which is less than 1. So this will be our first point. The second point is the obvious one, will be 0 and 0. And the third point will be 1 and 0.8. It's a point right here. And we join the 3 points, giving us a parabola with this shape here, with the equation y equals to 0.8 x squared. Now let's move on to drawing the parabola with the function f of x equals to 0.6 x squared. The 3 points we will have are -1 and 0.6. 0.6 will be a point just below this one. 0 and 0, 1 and 0.6. It's a point right there. Then we connect the 3 points to get the parabola with its shape, with the equation y equals to 0.6 x squared. And finally, let us now plot the parabola with the function f of x equals to 0.4 x squared. This parabola will have 3 coordinates. The first one being -1 and 0.4. 0.4 will be a point below the 1 of 0.6 x squared, the 0 and 0, and another point below this one, which is a 0.4 and a 1, or a 1 and a 0.4. We go ahead and we plot the graph, and we get the plot like that with the equation y equals to 0.4 x squared. As we can see, as the value of a reduces from 1 to 0.8, and then to 0.6 and 0.4, our parabola gets wider and wider. Now we clearly see the trend that as a gets greater and greater than 1, our parabola gets thinner and thinner. Similarly, as the value of a reduces from 1 going to 0, our parabola opens up more and more, or it gets wider and wider. We have now reached the end of our video dealing with the impact of the value of a.